In this quick little video, we're going to try to get across the idea of absolute temperature. Now, temperature is a reflection of the particle movement. And at 0 degrees Celsius, water is solid, but the particles are still moving. So if this is 0 degrees Celsius, there's still kinetic energy. But if we can keep cooling down particles infinitely, it'll go down to minus 273 degrees Celsius, and that's when particles entirely stop moving. So absolute zero, or 0 Kelvin, equals negative 273 degrees Celsius. This relationship is important for gases because if a gas particle stops moving entirely, it has 0 kinetic energy, its volume will equal 0 liters as a gas. And so we actually can't get all the way to absolute zero, but we can get very close. It's hard to simulate in a lab, but they've gotten within a fraction of a degree Celsius to absolute zero. And so if I have 25 degrees Celsius, that's going to be equal to 273 Kelvin plus 25 degrees Celsius. So it equals 298 Kelvin. If I have negative 25 degrees Celsius, it's 273 Kelvin minus 25 degrees Celsius. And that'll give me, so 273 minus 25 gives me 248 Kelvin. So there's still lots of energy there for the particles to move, but it is much cooler, less energy. If I was given 143 Kelvin, how many degrees Celsius is that? Well, if I have 143 Kelvin, if I subtract 273 from it, it'll be negative 130 degrees Celsius. So if I take the Kelvin value and then subtract 273 from it, I come up with the degrees Celsius. So all of the calculations that we're going to do in the gas unit uses absolute temperature, and it's always measured in Kelvin. We will be given values in degrees Celsius, or you may be asked for temperatures in degrees Celsius, but we'll never use gas law formula with degrees Celsius in it because it's ignoring all this particle movement and its relationship to volume. So absolute zero is a must for all calculations in gases.